With the royal flush done, we can copy and paste that. We're going to kind of use that as a jumping off point to create the straight flush logic. So straight flush will be a series of numbers in order, or card values in order, and they will all be of one suit. Where the royal flush had to be the top of them, include the royals. This one will just be any straight of 5 cards that are of the same suit. So since we've used a lot of the logic from the royal flush, where it's going to differ is here. And this is where we're going to have to make sure that the cards that are making up the 5 of the suit are actually one after the other. It could be any 5, a straight of 5, but it just needs to be an actual straight. So we need to do that kind of a logic. So after removing the duplicate values, we know that the remaining cards can be up to 7. And so we'll need to handle that as well, not just for 5, but for 5, 6, and 7 cards that are remaining after removing duplicates. This is because that straight could be anywhere in those selected cards. So for 6, it may be 2, 5, 6, 7, 8, 9. And that first card may not be the first card of the actual straight. Now we can update our tests to test to see if straight flush does what we want it to do. So we'll just change up the mock data. With a quick test, we can see that 2, 3, 4, 5, 6 does come out. With it working, which is always your number one step, make sure that it works. Then I'm going to go through and refactor it a little bit. It looks a little ugly and a little harder to keep in line. So what I want to do is we're going to have a lowest value. I'm going to set it as 15. That's the highest it could possibly be. Cycle through to find what the lowest number is. If I find a number lower, then it gets reset. The lowest value gets reset to that new number. I'm going to comment all this out real quick because I'm going to go through step by step and, or if statement by if statement, and change things up a little bit. So instead of having to go and get a card or a value every time and compare it to another get card, we are going to optimize it by each using the value we already have here. And so if the temp cards contains the lowest value plus 1 and plus 2, plus 3, plus 4, then we know that we have a straight. In order to handle figuring out which part of the hand has the straight, we know that there is either going to be the lowest value, and that'll be the first of the straight. So 2, 3, 4, 5, 6. Or it could be, say, 2 and then 5, 6, 7, 8, 9. Or it could be 2, 3, 5, 6, 7, 8, 9. So there's going to be 3 possible low values. If the card size is only 5 for that suit, then we know that it has to be the lowest value. It has to be the beginning of that straight. And therefore we can add to that lowest value and determine what that is. The second lowest value we know can only happen in 6 or 7 cards. And then the third value would only be able to work in 7, meaning there's 2 low, and then the top 5 are going to be the ones part of the straight. That is why we have to create 3 low numbers, which I do get second highest doesn't quite work with the name. Feel free to change that to second lowest value and third lowest value. The next highest ranking hand is going to be the 4 of a kind. So we're going to just copy some of this, get rid of the stuff we don't really need, and rename it. 4 of a kind is as it sounds for cards of the same value. The way I'm going to implement this is create an array that has, there's going to be a counter for us for each value of card. And then we're going to cycle through the hand and increment whichever index relates to that card. Then finally we're going to cycle through that array of basically as our counter of each card value and determine if any of those are over 4 or more.